Okay, it is September. It's November 6th. We are having trouble getting onto the iLearn website. Only one of our group members, Mac Folger, has been able to do it, and so we're all just gonna screen share off of his, and I'll take the test. Well, Mac's gonna take the test live, but Sarah and I will be writing it down with paper and submitting it later. All right.
Okay. Number 3 here. I'll read it off. Can you see that pretty clearly? Is that all good on your side?
Yeah, I got you.
Okay. In a pie chart, why are the slices different sizes? The answer is the size of each slice is random. Size is determined by the number of categories. I already pre-selected this one. You guys tell me what you think. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
That is correct.
Or the last one, pie charts are better with peanut butter.
Well, the last one's kind of true, but.
All right, I'll take the next one. How are pie charts and Pareto charts related? Pareto charts are constructed from tossing a coin several times. They're identical. And both those are incorrect, so we're left with C. But the only difference between bar charts and Pareto charts is the bars in Pareto charts are in descending order, largest to smallest in this case. So that was number 4, and that's also Charlie?
Yep.
Correct.
Wait, how did you read number 4 already? Okay,
the first two are the true false questions that are always true.
Well, no, I meant what I meant was, how are you seeing 4? Because I was still only seeing. Okay, now I'm seeing 4. Okay, keep. If you can scroll down, Mac, I'll do 5.
We might be having a little bit of lag here.
Okay.
Okay, I'm on 5. Tell me if you can see it.
Yep.
I got it.
Okay. P is the true population or the sample. It's the true population. So bravo.
Okay. I'll take 6 here. 6 is what is N? The sample size.
I feel like they're messing with us. These questions are too easy.
I know, it's too simple.
This is a preparation for the test. Don't worry.
All right. If P equals 1/4, what is the smallest N that satisfies the requirement? Oh, okay. Yeah. Okay, so hang on a second.
Let me pull up that rule right there.
Let me pull up the reading here. Let's see here. So we are.
Sorry.
Let's see here. We are over here. So NP needs to be greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. And P is 1/4. So your N needs to be greater than or equal to 40, and N needs to be 3/4. 40/3 is 10.3 something. So N needs to be greater than or equal to 10.3 repeating, correct?
All right, because it's 10.3 repeating, shouldn't it be 11 then? Because it's a sample size and we don't have a bunch of,
That is correct. Yeah, because we always round sample sizes up.
Yep.
You can't have a third of a population.
Well, you could have an amputee, but I don't feel like we could really concern with.
No, they wouldn't appreciate that.
Yeah, no.
Couldn't. Oh wait, never mind. So it's 11. Are we all in agreement with that?
Yep.
Well, my one worry with that is, it meets the second one, but it does not meet the qualification for N times P. If it's 11 times 0.25, that's less than 10.
That's also correct.
So,
right.
so where it has to meet both of them, I think that 40 makes the first one correct, and then obviously the second one's correct because it's much more than 10. Does that make sense?
Yes. Yeah. No. I see. No. I see what you're saying because if you plugged 11 into the first equation, it would not come out greater than or equal to 10. So yeah, I think that's right.
40.
Yeah.
Okay.
Good catch.
Good work.
Oh, I went through and did it some of these up till then before, luckily, or else I would have missed it. But okay.
All right. This next one's easy enough.
Whose turn is it here? Me?
Oh.
I'll take it. What is the mean
Yeah, I
of
think so.
p hat? Well, it's the same thing as p, so it's 0.4.
Yep. Nice.
It's 0.4. Okay.
All right.
Is that right? Is that?
I believe so. Hang on. No, yeah, that's right.
Okay.
The proportion would have been x over n. Right?
Yep.
Yeah.
Yep.
Yeah. E times 1 minus p all over n. Okay.
Square rooted.
And we're doing this for the last problem for number 8.
Correct.
Okay.
So, yep, I apologize. Let me go back up.
There, you're good.
N is 24 and P is 0.04. Or excuse me, 0.4.
Yep.
0.4 times 0.6 over 24.
Don't forget your square root.
All under the square root.
Yep. Yeah. Be sneaky.
So 0.24 over 24 is 0.01. The square root of that is 0.1.
Okay. Perfect.
It's not that I didn't trust you, Mac. It's just that we should probably do these.
No, please do them. I didn't go through and put the answers to speed it up. I just went through it because I like to. I don't know. It helps me go through and double do them or something. I don't know.
You're fine.
Yeah.
All right. So Brittany's batting average is 0.3. Makes sense. We want to know the probability she will get more than 35 hits in her next 100 at bats. So that would be 35 divided by 100. Is that correct?
Yeah, I guess. Yeah, I think so.
Okay. So that'd be 0.35, correct? Okay.
Yeah, you're right. 35 over 100. Yep.
Okay.
X over N. Or is it? It's not 0.3 over. No, it's 0.35. 0.35, is that what you said on 10? Is that right?
Yeah.
Yeah.
Okay. Yep.
All right. Number 11. What is the standard deviation? Okay, so.
You want the numbers again?
Yes, please. So it's
0.35 divided.
If p hat is 0.35, that means that regular p is 0.3, correct?
Yes.
So it's 0.3 times 0.7 over 100.
Isn't the square root of 100?
All into the square root.
Is that right?
I think so, isn't it?
Yeah, so you figure it out and then do it.
Wait, so it's under the square root of 100, correct?
I thought it's the square root
No,
of
you do
everything.
the equation and then square root it. Yep.
Wait, square root of everything?
Yeah. That's
Okay.
that's how it is in the book anyway.
No, I trust
Yep.
you guys. For some reason, this chapter, as I was reading through it, it might just be because I'm just so annoyed over the test. It's just, I'm having a hard time even processing all of it. It's just not happening today.
I got 0.046.
Cool.
Does everybody else concur?
Hold on.
All right, hang on. I'm gonna go add a log to the fire. I'll be right back.
Was that some, like, euphemism, or was that an actual thing?
It's an actual great fireplace.
Okay.
It's cold today.
Wait, I got 0.022. What do you guys get?
0.046.
Okay, so I took 0.35 minus 0.30 divided by 100 and square rooted all of it.
It's 0.3. We decided p hat is 0.35, and
Yes.
regular p is 0.3.
Yes, so 0.35 minus 0.3 divided by 100 square rooted. Correct?
No, you're going to use your equation p times 1 minus p all over n, and then square root that.
Oh, okay. I see.
0.3 times 0.7 divided by 100, and then square root of that.
Okay.
Is p hat the correct term, or is that just really clever and something we're going to adopt?
Well, that's
No
the
idea.
right term.
Ah, nice.
Okay. So you guys got. Oh, heck. I never read this chapter. Okay, so 0.3 times 0.7 divided by 100. Second square root. Second answer. Where are you? Okay, 0.46. Got it.
Cool.
0.046, is that?
Yeah.
Just make
Yeah.
sure you got the right
Yep.
zeros in there. Okay.
Yep. Thank you for catching
All
that.
right. Now this one's the big one. All right. So 0.35 minus 0.3 all over. Okay. We did the last one was the standard deviation. That's what we did.
Correct.
Correct.
Okay. Oh, that's actually not bad. So it's 0.05 over 0.046.
Where'd the 0.05 come from?
The thing is p hat minus p.
Oh,
And
got
so
it.
p hat is, yeah. So I just skipped a step.
Okay, that's what. For some reason, I was looking for the z-score for the standard deviation. That's what I was doing. I was like,
All right, so I got 1.087.
I got 1.0869.
Yeah. So
Yep, you're right.
yeah.
You know, I'm just going to continue to try and reinforce that you guys are right and you guys are doing great today.
So I just real quick on that one, instead of using our standard deviation of 0.046, which is rounded, I just plugged in the whole equation and got 1.091.
Okay, that's probably more correct.
Yep.
Do you want to double check me though?
No. Oh yeah, I can. Let me double check.
I can double check me, but I think that's the unrounded number.
Fair enough. Good catch. Although I've laughed because sometimes they want the unround number, and then other times they expect you to use your answer that you got. That's also I've seen that a couple times this class.
Gosh. This is gonna be so many parentheses. I'm really gonna get. All right, hang on. So square root of parentheses 0.3 times another parentheses 1 minus 0.3 in parentheses over 100 in parentheses. Yeah, okay, so I got 1.091.
Okay.
Cool. That's what I got too.
Good.
Cool.
And then, oh boy. What is the probability Brittany gets at least 35 hits in her next 100 at-bats?
Okay, Mac, I think you're the only one who has the normal probability app open.
That's true. Sorry. I was like, I'll take. No, I won't.
So that's
That look right to you guys?
Yeah, 0.138.
Okay.
Oh wait, hang on. Yeah, 0.138. Sorry, I put the decimal in the wrong spot and freaked out for a second.
It's over 1. Something's wrong.
What is this? 138%? How?
Sign her up.
14. Okay.
Losing the election, so getting less than 50% of the votes. Okay, so.
Okay, so that equals. Where are you, my lovely little equation? Okay.
All right, so let's see here. Well, so first off, we can calculate the standard deviation just fine. Right?
It's 2,000, right? Not 20,000.
That's 2,000. Yeah, you're right.
Okay, good. Sorry, I wrote it down wrong. I'm like, wait a minute, that doesn't seem right. Okay.
Four, 8 over 2,000.
I got 0.011111111.
Yeah, me too. 0.01. For all intents and purposes, 0.011.
Yep, 0.011. Like I thought, sorry, we have all the numbers. I'm like, no, it's just 0.0.11. Why am I forgetting?
Hang on a second. My insulin pump's freaking out of me.
Okay. Mac, thank you for being a champ and screen sharing.
Oh, sure.
Seriously though, we'd kind of be up a creek if it wasn't for you there, Mac.
I think we'd be rescheduling the meeting for some time later today.
Yeah, I know.
Oh heck.
I hate when the computers go down.
Oh.
It's well, I feel a little bit better that it's because usually I'm the only one who's having computer problems.
I think there's an issue with the site. Maybe I'm wrong.
Wait, which one did we just, was that number 14 that we just did?
14, yep.
Hang on a second, because did I skip one in here?
Oh no.
7, 8, 9, 10, 11, 12, 13, 14. Okay, hang on a second. All right.
Shall we double check here?
What was number 13?
0.138.
Okay. How about number 12?
1.091.
Okay.
Or 1.087, depending what they choose to use.
They'll do 0.91 or 0.91.
Yeah.
Okay, what's 11?
0.046.
Okay, and 10 is 0.3. Is 10.35?
Yep.
Okay, and then is 9.1.
Yep.
And then 8 is 0.4.
Yes.
That's really bizarre. I had a random extra. I had a random extra number in there. All right, whatever.
All right. So back to 15.
Okay. Yeah, so 15 we decided was 0.011, correct?
That's 14.
14, sorry. I haven't changed that number yet. Okay.
Poor
Okay. All right, the Z score.
So first we'll need to figure out p hat.
Yeah, so p hat, the probability calculation. So the p hat is x over n.
Yep.
Which that's 52. Is that 50 or 52 over 2000?
I think it's 50. What does everyone else think?
Can you go back to the information again?
Yeah.
Is it 50? Wait, where are we getting this from? Because it's the sample size is 2000.
Yeah.
Oh, it's 50. You're right. You're right.
And here's the next question. Is it 50 or is it 0.5?
Oh, bloody hell. I mean, oh, blasted heck. Blasted heck. Oh. I'm going to say 0.5.
I think it's 50. Oh shoot, no, 50% of the votes. Yeah, I don't know.
Yeah, oh, gosh.
Let's see. What do they do? What do they
Here's
do?
our
They
answer.
did one of these. They did one of these in here.
It's got to be I'm going to say it's got to be 0.5, my friends.
Oh, hang on a second. Hang on.
Okay.
Okay. So in the example when they're figuring out the Z score, Mac, if you want to scroll down to 3.3.2 in the textbook.
Okay, hold on. I got the textbook open.
Example political elections. It has basically the exact same thing that we're doing right here.
Okay,
And
so
they use 0.5.
they do use 0.5? Okay.
Yeah.
Alright, so I've got, wow, I'm curious to see how it goes. Is it 0.003 with rounding?
Hang on a second.
Yeah, 0.00025.
Yep. So 0.003 rounded, correct?
Well, we need the Z score. We're not. That's only part of the p hat is only needed to calculate Z score. So keep going on your Z score.
Okay, but the p hat is the 0.003, right? That is
Yes.
p hat.
In the example they just use 0.5 for the p hat.
Oh, really?
Yeah.
Well, let's do that too.
Okay. Well, we like to overthink this. Okay. Okay.
Now a ton of parentheses.
Okay, what are we looking for again? I forgot what we're even looking for.
The Z score.
Z score? Okay. Alright. Alright, and we found the standard deviation on the last one, right?
Yes.
Yeah, but we probably want to.
And so it's a point. Oh, it's a 0.5 minus the 0.52. We were way overthinking this. So it'd be 0.02.
Negative 0.02 actually.
Oh, wait, no, because it'd be the 0.52. No, you're right. Negative.
All right,
work.
so for the Z score, I got negative 1.79.
Okay, so I got negative 0.02 divided by negative 0.11. I got negative 1.8181818181.
I got negative 1.79. Is that what you also said, Mark?
Yeah, that's
What?
what I got.
How are you getting 0.179? So we take the negative 0.02 divided by 0.011, right?
Well, you got to do out the equation because that's the rounding error that we did in the last one as well.
Okay, so negative 0.79.
179, negative 1.79.
Okay, negative 1.79.
Yes.
Okay.
Is that what number 16 is there, Mac?
I don't know. We'll see.
Okay.
Just getting ready.
Good.
There you go. Yep. What is the probability? The survey results will show that they're losing 0.037.
37? Oh, yeah.
Okay, got it. Thank you, Mac. You are a gentleman and a scholar.
Oh no, just a gentleman.
Let's see how this goes.
Okay. 0.037. I really hope we don't have to do this again.
You and I both.
No, right? This
100%.
Excellent. Good work.
Awesome.
All right.
All right, guys.
Okay, should we send this over to Becky too so she can have the video?
Yeah.
Oh yeah, I'll email it to her.